Okay, good morning to all of you. Today is the last class, and I will discuss mainly some numerical problems that you may expect in your coming instant examination. Okay, and if you have any doubt, you please clarify. Okay, I will discuss some problems, but before that, let me share something.
Sir,
Yes, yes. Any question, please?
sir, in the assignment you gave,
Yes, yes. I have given assignments, but
yes,
you will try to solve only those numerical problems. Other things are not required. Okay. Theory part is not okay. It is not required to submit. You may selectively submit only the numerical problems. That is enough. And if
Sir,
possible,
there,
you can do all these questions. You can submit, no problem, in the Google Classroom. If you, if it is possible for you, then you can submit all the answers. Otherwise, you can submit only the numerical problems in the assignment. And in the laboratory assignment, you please write down only the theoretical methods and procedure. And you may not write the data that is given in the theory because that is not that you have not done. Okay.
sir,
Yes.
so lab assignment and class assignment will be in same PDF.
When your exam will be there, 18th April,
No,
right?
sir, we have to submit in the same PDF in the classroom.
Then
Sir, while submitting the three assignments, two lab and one class assignment, are we supposed to merge the all three
yes, yes,
answers in a
yes, yes,
single?
yes. Single. PDF, no problem. That would be better for me.
Okay,
Yes,
sir.
in a
sir,
single PDF
if you have
format.
already written the observations for the lab experiments, it's fine, no, sir? Or
Okay, those who have done it separately, or you can do a single PDF, no problem. But for lab assignment, you don't require to fill up the table. You write only the theory and experience and the procedure. Okay.
okay, sir.
Sorry. So this is a problem. Suppose you can consider that electrochemical cell. Okay. You write the problem that we have an electrochemical cell, and these are the data that is given. Okay. So the numerical problem is somewhat like that. The problem is there for an electrochemical cell with two electrodes. One is Sn plus 4, Sn plus 2, and another is Sn plus 2 is n. Okay, and these half cell standard potentials are also given to you. Sn plus 4 to Sn plus 2, that is 0.15 volt, and that of zero of Sn plus 2 to Sn, that value is given as 0.136 volt. Okay, calculate calculate delta G zero of the cell. Calculate delta G zero of the cell. Then how will you proceed? You try to solve this. So this is the problem. The half cell electrode potentials are given, and you are asked to find out delta G zero of the cell. How will you proceed? So what is the procedure? You can proceed like this. First, you have to identify.
Sir, we have to find the E0 cell first.
No, no, you have to calculate delta G zero of the cell. So
Yes, sir.
what is
That
the,
is NF E0
no, no,
cell.
no, no. Please listen me. Actually, you have to find the cell in which the total cell EMF should be positive. So in this way, you have to design the cell. That means which electrode you should write in the left part and which electrode you can write in the right hand side part. That is your oxidation part or anode chamber, and what is the cathode chamber. That you have to identify first. Say for that example, I have written this equation. This is one half cell, right? Standards to standing. And this potential is given Sn plus 4 to Sn plus 2, it is 0.15 volt. Okay, but the reverse, suppose Sn plus 2 to Sn, this electrode potential, uh, this electrode potential is 0.136, right? So you should write it, yes, you should write it in the reverse format, in the reverse format. No, sorry. The question is that this is one question and this is another question. That is, you have to calculate Sn zero of this electrode. This is another question. Also, find out this question. That is E zero of Sn plus 4 to Sn. Right. So this is the another part of the question. So how will you proceed? Okay, first you have to find out whenever you are asked to calculate delta G0 of the cell, then you have to first write down what should be the cell actually. Actually, it should be here. Here it should be negative sign. Okay, minus 0.136 volt. Just carefully note this. Okay, this is actually you can proceed like this. This part is very simple for you, but overall you have to first I am solving this part, okay, because it is done here. So how will you find out E0 of Sn plus 4 to Sn, given Sn plus 4 to Sn plus 2 and Sn plus 2 Sn? Okay, so we proceed like this. You just write down the corresponding cell reactions. Okay, now we use this formula. This is the single formula that you have to remember, because you cannot add the potential of a of two reactions, right? To half cell reactions, because potential is not the extensive property, but free energy is an extensive property. So that's why we can calculate delta G0 of both half cells and we can add them. Then we can get from that this is the reactions. Okay, say like this, write like this. Sn plus 4 to Sn plus 2. 2 means NFE. N is the number of electrons, so 2. F is the Faraday. And E01 is, I am writing just in short because it should be multiplied by 0.15 volt. And this is equal to minus twice F E0, where E0 is giving this here. Okay. Now you just add these two equations. Suppose if the reverse would be given, say Sn to Sn plus 2, then you have to convert it like this and put a negative sign, right? So this is very important. That means you have to arrange the half cell reactions in such a way so that if you algebraically add these equations, then you will get these desired reactions for which half cell potential is requested. Okay, that is, you are asked to calculate Sn plus 4 to Sn. So that means this is the straightforward case right now. And what should be delta G0? If you add these two half cell reactions, then the corresponding free energy change will also be added automatically. Okay, so delta G0 of this reaction, combined added reaction, that is given by. Okay, any confusion at this stage? Okay,
Yes, sir.
just simply add it. Now, what is delta G0 of these reactions? This is given by the standard formula. Now here we put n equal to 4 because 4 electrons transfer takes place. Number of electrons taking place is 4. Yes, this is the expression of 0. Half of E10 is 0.15 and it is minus 0.136 volts. Okay, you put it here and this is the answer. Okay, is it all right?
Sir, why
Yes,
there is a
sir.
minus sign
Hello,
in the middle?
any confusion?
Sir, why there is a minus sign in the middle?
Minus sign in the middle.
Yes, sir.
What is 0?
Sir, E02 is minus 0.136.
Is 0 Sn plus 2 to Sn. What is the value?
Oh, sir, you wrote a minus. I didn't notice it. Okay, sir.
Is it all right?
Yes, sir. Yes, sir.
But sir, why sir the some value is positive and some value is negative?
That you should understand. That is the nature. It depends on the nature of the electrode, right? Whether it is oxidizing electrode or reduction electrode. That you can guess. Suppose I can explain it in this way. From this data, say this one, consider these two reactions. If I ask you which is the most reducing agent, strong reducing agent, how you can justify? Of these two reactions,
That those who have, yeah, not SRP value higher,
Sn,
that is the
whether
better oxidizing agent.
Sn plus 4 or Sn plus 2, which is the stronger reducing agent or oxidizing agent, Sn plus 4 oxidizing agent, right? Sn plus 4 is an oxidizing agent because it absorbs 2 electrons, so it is reduced to Sn plus 4. Okay. Now the question is which is stronger reducing agent, oxidizing agent, Sn plus 4 or Sn plus 2? That you can guess from this value. Now for Sn plus 2, what is delta G0? Minus twice F into zero point 0.1. Okay. But for these reactions, delta G0 is equal to is negative, so it should be positive twice F into 0.166. Now my question is, which is spontaneous as per thermodynamics?
First one. First one.
Because the energy change is negative, right? So that's mean Sn plus 4 is a stronger oxidizing agent, and Sn plus 2 it has no oxidizing properties at all as per the given data because free energy change is positive. Okay, as per the given data. This is the answer. Okay, now once you know, say Sn plus 4 to Sn plus 2, you have calculated this. Now, if you write in the reverse direction, then it should be Sn2 Sn plus 4, the value would be this. Now, what is free energy change for this reaction? Sn2 Sn plus 4. This is the oxidation potential as per given data. It is like this, 0.28 joule. So that means Sn in itself is a oxidizing agent or reducing agent.
Reducing.
Can you guess?
SN
Sir,
is
reducing.
Yes, because
positive
here are the things.
delta G naught value.
Okay, and always take 1 Faraday. The value of 1 Faraday is 96.5 not 2 coulomb. Okay, now I can give you other problems that you can try. Suppose I'm giving you another problem. Let's try this. You should know. Do you know calomel electrode?
Yes, sir. HgCl2.
So what is calomel electrode? So you should write down the half cell reactions. Write down the half cell reaction. Can you do yourself? Can you solve this problem? Hello.
Yes, sir.
So I think these are straightforward problems. You can solve it. Okay. So I can give you another problem. Say, okay, I just write in black ink. This is another numerical problem. Say conductivity of a saturated solution of barium sulfate is 3.48 into 10 to the power minus 4 Siemens per liter, right? Now the conductivity of pure water, the conductivity of pure water is say zero point 0.5 into 10 to the power minus 4 Siemens per liter. Okay. Now you are asked to calculate solubility product of this sparingly soluble salt, that is barium sulfate. How will you proceed? Given conductivity of saturated solution of barium sulfate and the conductivity of pure water, both are given. Can you guess what are the units? From the units, what kind of conductivity these are?
Sir, molar conductance.
Molar. So you please carefully read those units and basic things, because I think you have already forgotten those things. But the question is, how will you calculate this?
Sir, we have to subtract the conductivity of BaSO4 from H2O, and then we have to put lambda m equals to 1000 kappa by m.
Of course, we have to supply another quantities, that is conductance of
Yes, sir.
barium plus 2 and that of conductance of sulfate ions. So these unconductances should be given, right? Actually, the value are uh, what are their values? Can you guess? For barium sulfate, I think this value, say for actually what is the, because unless you do not know this quantity for barium sulfate, then you cannot proceed further. So here it, the sum is sometimes maybe 127, maybe for that sulfate ion, and for conductance of this barium ion is 130 Siemens. Uh, this units should be multiplied by 10 to the power minus 4, right? What is the unit of equivalent conductance? Siemens meter square per equivalent. Okay, and these are specific conductances. That is 3.48 into this and this. So these are the data given. The lambda 0 barium sulfate is given, and so how will you proceed? So you can see my previous discussions. You just find the formula where you can put the data. Yes, here you can find the discussions. We have discussed it somewhere. Okay, I can show you. Yes, yes, yes. Yes. This is the part. Okay. I have given the example for silver chloride. So we have to calculate gram equivalent parts, that is equivalent conductance, that is given by this formula. Okay. So LS, that is specific conductance of salt and water, that is given to you. Okay. And this is given to you. So you can calculate the solubility in a straightforward way. Do you follow this prescription? Hello.
Yes, sir.
Yes, sir.
So you have to solve like this for barium sulfate. So you can proceed like this. Solubility of barium sulfate, that is equal to specific conductance of the solution, that is for the given problem here 3.48 is value, solution minus specific conductance of pure water divided by lambda 0 of barium sulfate. And this quantity, these values are given here, say 3.48, 3.48 into 10 to the power minus 4 minus 0.5 into 10 to the power minus 4. The units are all specific conductances. Units are given in centimeter per, sorry, Siemens per meter, that is ohm inverse per meter. So there is SI unit. And lambda 0 barium sulfate, that we have calculated like this. So 127 plus 320. This must be supplied to you, otherwise you cannot calculate. Okay. So using these expressions, whatever the answer that you will get, that should be in, that we have used gram equivalent, gram equivalent. Okay, this is the answer. Sorry, this is the solubility, and solubility product KSP should be simply, because barium sulfate ionizes as barium plus 2 plus sulfate, so it should be, this is the solubility, that should be S square. And S is calculated using this. Okay, so this is the problem, and this is the solution. That is, once you know the specific conductances, you will calculate Okay. So for those who are still have some fumbling, you please carefully see this problem once again for and repeating, because all these problems are important for your very similar types of problems you can expect in the final exam. So that's why this is the general expression of solubility. That part I have to given from these expressions. Because it is given in Siemens per centimeter. So it is given by this is the specific conductance, and normally if you write 10 to the power 3 by S, when your solubility is expressed in gram equivalent of salt per liter, right? But here this factor is not required. In SI unit actually lambda equivalent that should be equal to specific conductance Ls by that concentrations. That is C in equivalent concentration, gram equivalent concentration, or normality, whatever you can see. C is in not normality, it is a concentration if it is expressed in mole per meter cube. This is the concentration, and this is Siemens meter square. And this unit now LS as Siemens per meter. All are in SI unit. So this 10 to the power 3 factor will not appear here. Please carefully note it. Please carefully look at. LS, if it is given in Siemens per meter, then this 10 to the power 3 factor should not appear here. And C is here in SI unit, it is moles per meter cube, right? And it maybe is a gram equivalent, okay, then it should be that amount, that gram equivalent concentration per, that is gram moles per meter cube. Better you write gram moles, okay. If it is molar conductance, this simply mole per meter cube, okay. So anyway, so these two data that is here, that solubility here, we keep it as gram equivalent per meter cube, okay. So you can use straightforward these expressions. So why that is mobility or transport number of H plus and H3 sorry, H minus is so high, that I already discussed. That problem also, these sorts of things you should remember, okay. So this problem I have solved it, okay, not per liter but per, it should be this is what is the unit of this? This will have an unit in gram equivalent per meter cube. Okay. In a second. Now some other problems I can discuss. Okay.
Sir, can you please scroll sum up? Yes, sir. Yes, sir. Thank you, sir.
Is it okay?
Yes, sir.
Now there is another important problem that you can expect that say at 18 degrees Celsius equivalent conductance, that is lambda EQ of sodium nitrate. I'm not writing like this. Straightforward. You write lambda E, EQ means E of sodium nitrate. This electrolyte. It is given as 105.3 and ionic conductances lambda plus of nitrate. Sorry, you don't write plus here. Just put nitrate ion, that is given as 61.7 Siemens centimeter square, and that of lambda of the sodium ion. Right. Okay. Ionic conductance is given only this, and calculate mobility, sorry, and transport number. This is not given. That is calculate T, that is transport number of sodium, and the mobility V plus the solution. The solution. So these values corresponds to a very dilute solution of sodium nitrate. So in a very dilute solution of sodium nitrate, the conductance, equivalent conductance measured of the salt is 105.2, and that of nitrate ion, the ion conductance of this nitrate ion is 61.7 centimeter square, and that of sodium we have to calculate Na plus and V, that is mobility. This is the transport number of sodium ion, and this corresponds to the mobility of Na plus. How will it? So this is a very interesting problem.
Sir, we have to convert equivalent conductance of sodium nitrate into molar conductance, and then we have to apply Cholera's law.
No, no, here actually sodium nitrate and it is univalent electrolyte. So for this electrolyte or salt, equivalent conductance and molar conductance both are
Same,
identical.
same.
Right. So given the answer is somewhat like this. Because it that is lambda equivalent that is given 105.2 Siemens centimeter square. This is not in proper SI unit. In most of the books you see they use this is SI unit, but this is not SI unit. That is the problem. Okay, so you have to calculate like that. So lambda equivalent conductation, coin conductance of nitrate ion is given 61.7 Siemens centimeter square. Now, for this case, what is lambda Na plus? How we can calculate that?
Subtracted.
Yes, because this is very dilute solution. So this is almost equal to lambda is 0, right? Very dilute solution. So we can calculate lambda Na plus equal to 105.2 minus 61.7, which is going to be 43.5 centimeters square. Okay. Now you are asked to calculate transport number of what is that? E Na plus. How to calculate this? This is equal to lambda Na plus to Na plus divided by lambda.
Na plus lambda NO3 minus.
Yes. So it should be simply 43.5 by 105.2 and it will
0,
be around
0.41. Yes.
Once you know this, then you can calculate what is the transport number of this. Sum of the transport number of the ions in the solution is equal to 1. So since it is a single electrolyte solution, so transport number of nitrate ion you can easily calculate. You subtract. Okay, that is 0.50. Anyway, but what is the mobility? The question is mobility. You have to calculate the mobility of sodium ion. What is the formula? How will you calculate? Actually, you can write down this formula. Transport number of nitrate ion, sorry, transport number of sodium ion is equal to mobility of Na plus by mobility of Na plus mobility of nitrate ion, and this figure is 0.41. And so there is an equation, what is lambda Na plus? Na plus. What can we write? There is a formula Z F V Na plus. Standard formula is lambda I that is ion conductance is equal to Z F Faraday and mobility of the ion. This is the valency of ion. F is the Faraday of electricity and Vi is the mobility of ion. Mobility. Okay. So for sodium ion, Z is equal to 1 into Faraday 96520 into Vna plus. Now this is the expression. And okay, so you can calculate this figure. Now this quantity, that is lambda Na plus, we have calculated, sorry, it is given, not we have calculated, 43.5
Yes.
already calculated, 43.5 equal to 96520 into Vna plus. Hence, Vna plus mobility of this sodium cation is 43.5 by 96520. Okay, and this figure is coming out to be what? You can justify yourself, but you calculate.
Sir,
Okay,
4.50 into 10 to the power minus 4.
and the unit should be centimeter per second.
Centimeter per second.
Okay, so in this way you have to solve the problem. Okay, so these are the some problems. Maybe I have given also another related problem I can give you. See. Okay, similar problem I have just given, but I have not discussed because these problems is exactly similar to this. So you can solve it easily. That is at 18 degree centigrade. Okay, just one color. Yes. Okay. At 18 degree centigrade, molar conductivity of a dilute silver nitrate solution is 115.8 Siemens centimeter square. And given transport number of silver iron 0.466 and that of transport number of nitrate ion is 0.534 respectively. Calculate uh, lambda nitrate ion and lambda silver ion. Calculate this and this and also mobility of silver ion and that of nitrogen. Okay, so I think you can follow the same prescription or same that I have done in the last class, sorry, last example. So hopefully you can follow the same algebra. Okay, and interestingly, what you can get that you are asked to first calculate the unconductance. Okay. So you can check or you can verify that from equation 1, similar, that is you can write lambda plus dilute solution almost. So their conductance you can add and you get 115.8 centimeter square and transport number of silver ion that would be equal to lambda plus by lambda plus lambda minus means nitrate and average and that value is given 0.66. So you can write down from this manipulation lambda plus would be equal to 0.66 by 0.534. So let this is equation 2 and let this is equation 1. So two unknowns and two equations. So I think you can calculate lambda plus. And another thing is that regarding the mobility, you can verify that T silver ion, sorry, T silver ion by T uh, nitrate ion, that would be equal to what? Can we write lambda silver ion by lambda nitrate ion. Right. But you can verify. So this is the procedure. This is the hints. Now, can you explain that why why transport number of each class is much larger than transport number of potassium? I think you can explain that, right? And the mobility. Okay. So another numerical problem I can discuss. There is a problem like this. So can you justify this transport number relation, potassium ion and H plus?
So due to Gurtha's conductance mechanism.
Yes, I have shown it. I already
Yes, sir.
discussed it, right? Okay, so you
Yes,
can
yes.
follow. You can answer. Okay. Now, the another important question is that the mobility of Na plus, that is given as 7.623 into 10 to the power minus 8 meter square per volt per second. This is given. Now calculate calculate lambda in a class. So the relation, I think you know that lambda hints that hints. What is that? Lambda in a plus equal to z f v in a plus. Now z valence is 1. Faraday 965 coulomb, and this is in SI unit is given, so no problem. Just write 6 to 3 into 10 to the power minus. But the answer will be in, in which unit? Can you guess? What should be the answer? Siemens meter unit. Right. Sorry. Sorry. Siemens meter square. Okay. You check it, please. Whether can we write this or not. Is it clear?
Sir, 7.36 into 10 to the power minus 3.
Minus
3.
why 3? It is minus 8. If you multiply it, what is the value exact? 96500 into 7.623 into 10 to the power minus 8. And the answer would be Siemens meter square unit, because mobility is given meter square per volt per second. Okay, check, check it. Now the next question is Now any doubt? Now consider sodium chloride. Another say another problem. So this is the answer. Okay. Now another numerical problem. You can try yourself. Okay. So these are in the assignments. I think most of the problems are given in the assignments. So I think you can do it. Sometimes a problem you can expect that suppose if external electric field, the potential difference of these two electrodes delta phi is given as 0.15 volt, right? Where the electrodes they are 25 centimeter apart, right? So you are asked to calculate velocity of the ion. That is, you are asked to calculate U Na plus. How will you fix it? So you think you can do it? What is the formula? Hello, can you hear me?
Yes, sir.
Yes, sir.
So what is the hints?
Sir, we have to calculate the electric field by the help of potential difference and length.
U Na plus equal to what is the mobility? Mobility is the velocity of the ion per unit potential gradient. So you can calculate mobility of the ion which is equal to velocity of sodium ion which is per unit potential gradient. What is the potential gradient? 15 volt across the 25 centimeter is the distance between the two electrodes. Okay, and so from this expression you can calculate if you want to express in it meter per second, right? Then once you know uh, UNA plus equal to velocity of this is the velocity. UNA plus denotes the velocity of sodium ion and VNA plus denotes mobility of Na plus I. So U plus, sorry, mobility V Na plus equal to this. And it should be equal to what? To convert the dimension, so so the velocity U Na plus will be equal to V Na plus into 10 to the power 4 into 15 by 25, so that unit would be equal to meter per second. Now justify whether it is online, because it is given centimeter. So we make it, what is the unit of this? Suppose you were asked to calculate this, and this is given, say mobility is given. What is the unit? That mobility of sodium ion is given 7.623. What is the unit? What is VNA plus? Mobility of sodium ion
7.623 into 10 to the power minus 8.
7
623.
into 10 to the power minus 8 meter square volt inverse per second. So that's why if you want to put this, and this is centimeter, so to make the uniformity to make it uniform, so this factor will come out 10 to the power 4, so that this would be like this.
So 10 to
Because
the
meter square is there, na? 25 centimeter and length. L is equal to, that is the distance between two electrodes, 25 centimeter. So we have to express in meter. Then 25 if you convert it into 10 to the power minus 2 meter, then we write,
yes, sir.
okay. So it is meter square is there. So that's why 10 to the power 4 factor comes up in the mobility.
Sir, the final answer should be 4.57 into 10 to the power minus 4
4.57
into
10
10
to
to
the
the
power
power minus
minus
4. 4.
meter per second. So this is the answer that you can do. So this starts up numerical problems, and another problem I can discuss with you. This is the last problem. The electrochemical cell has the reaction given. is a cell reaction. Suppose this is a cell reaction which is given at 25 degrees centigrade. SN plus Pb plus Q. So SN plus Q plus Pb. Oxidation reduction reactions. Now activities of lead ion is say 0.3 and activity of tin plus 2 is 0.6. Sorry, activity of Sn plus 2 is 0.6 and that of lead is 0.3. And C0 of the cell it is given as a 0.012 volt. Now you have to configure configure the cell or design the cell and calculate free energy change. Okay, so this is the question, and I think you'll be able to solve that. This is a very interesting problem. You try to solve and tell me the answer. What is delta G0 cell? And write down the cell. Design the cell. Okay, this is the question. Please try to solve it. Can you solve it? Hello.
Yes, sir.
You see, many of you are not interested. Only 7 of you are left. Right? It is very interesting because I know that the problem is that in the online exam you have a plenty of opportunity, right? Advantages, and that you are utilizing fully. That is the problem. But still, there will be many of you get supplementary every year, even in online mode. This is interesting. And we have to give some additional marks for your path. Many of you, most of you. I don't know what will be their in future, what is their target. Ultimately, a job like just like a clerk in a company, because most of the Indian company they will provide you only clerical job, mostly all in the excepting government sector, few government sectors and few uh, companies, very few, most of it, but not beyond that. Unless you have academic ambitions, you will have to do this small job like this engineer, and that will be happy, and your family will also be very, very happy. And that is for your interest to come to this engineering institution. And this is the kind of education, and that is your interest or motivation. Okay? So all these things are very unique. I don't know what is your future because you're too much reluctant. Okay. So I'll discuss because if your five are there, so still I'm bound to discuss this. But you see, many of your friends will copy and will submit the assignment. That is the problem. That is the big. Okay. I know the things are very simple because all of you are done in your high secondary examination, but your rank is not at par of your merit anyhow. So how will you proceed further? So potential, then potential, Nernst equation, you know that, okay? That is E equal to E0 cell, E cell, E0 cell, minus T by NF ln reaction quotient. And actually, I am writing E instead of cell, E0, minus this figure, it is coming out to be 0.059, so 0.0595, because two electrons will be transferred.
Yes, sir.
So we write 2, and then ln uh, activity of plus 2 by activity of lead plus 2, because of these expressions, Sn plus 2 by this. And activity of solids are equal to 1, so that's why we do not consider this. Activity of solid metals taken as unity. So E of this cell, that is E0 is 0.014 minus 0.059 by 2, and then the value is zero point 0.6 by zero point 0.3. So you calculate this E and then use what is the
Hello,
frequency?
sir.
Yes,
Sir, can we take that 0.059 as 0.06
okay,
for
no problem, no problem,
calculation?
no problem. So delta G equal to minus twice F. This answer. So 2 into 9, 6, What is the value of this? You calculate.
Sir, it's a negative value.
Maybe. What is that?
Sir, I'm getting minus 6.44 into 10 to the power minus 3.
6.44 into 10 to the power minus 3.
Yes, sir.
Okay. So that means actually it should not be negative. I don't
I
know.
also get that, sir, the negative.
Okay, no problem. That means the reverse combination. Okay. The cell reaction should be occurred in reverse direction. That doesn't matter, no problem. Okay. Because negative sign is there and negative, negative, positive. Okay. 6.44 into 10 to the power minus. So that is the value. And so that means the cell reaction should be designed since it is negative. The cell reaction should be like this. PV plus Sn plus 2, PV plus 2 plus Sn. This is the correct configuration. Configuration of the cell. That means you have to write lead plus 2 and Sn plus 2. Okay. This is the cell configuration or design, whatever it is. Okay. Reverse, because for the cell reaction delta G is negative, so the cell should be designed in the reverse way. That means electrode should be written in the reverse direction. Okay. But at this concentration, standard EMF is positive, but when you give the solution contains certain amount of this tin and lead ion, then the cell will operate in the reverse direction, and this is the correct design of the cell, right? So this is very important because why you have to design so that delta G of the cell, delta G should be negative.
Negative.
That is the study. Okay. Anyway, so I think this is the last class before your final exam.
Hello, sir. Can I ask something?
Yes.
Sir, I have found some question, the previous year's question,
Yes.
final semester. Like,
Yes.
sir, one question is asked: illustrate the double layer structure at the electrode solution interface or the redox electrode. Sir, how we are
No,
supposed to answer this?
no. This question will not be coming. It's out of syllabus.
Okay, sir.
Okay. Okay. So thank you all for attending this class.
So did you take the attendance?
Sir left. Sir is frustrated with attendance.
বেরিয়ে গেছে স্যার।
রেগে বোম। কেউ কেমিস্ট্রি পড়তে চায় না।
হ্যাঁ ভাই সেটাও ঠিক না, বাট লাস্টেরটা ওগুলো তো বোঝা যাচ্ছিল।
না কিন্তু দেখ, কোনো ক্লাসে এরকম অ্যাটেন্ডেন্স হয় না, এর ক্লাসে যতটা হয় এরকম 10, 12, 30 জনের বেশি কোনোদিনই হয় না।
আজকে তো হাত করে দিয়েছে ভাই, 10-15 জন।
आज था 30 लोग था स्टार्टिंग में।
हाँ एकदम
30
फास्ट पेस।
30 30 30 लोग थे, लेकिन सभी एक एक करके लेफ्ट कर दिया।
सर क्या 2 घंटा क्लास लगेगा वही होगा।
क्वेश्चन तो यही बनाएगा, फाइनल का क्वेश्चन तो यही बनाएगा, मतलब
वही वही
यही तो डीन है ना, तो केमिस्ट्री का
वही।
क्वेश्चन नहीं बनाता है।
ठीक बोला भाई।
और फाइनल मार्किंग भी यही करते हैं, मतलब तीनों टीचर्स अलग अलग करके मार्क्स देने के बाद कॉम्बाइन भी यही करते हैं।
यही करेगा।
हाँ ये डीन है, मतलब मैथ्स का, मतलब हर एक सब्जेक्ट का जो डीन है वही सब काम करता है, मतलब
एचओडी
मैकेनिक्स
है क्या
है।
केमिस्ट्री का?
भाई आज
वो
तो
तो
मेरा
झूमर
कंप्यूटर
ना
का वाइवा भी है।
एचओडी झूमर ना ना।
नहीं नहीं, हाँ एचओडी वो ऑर्गेनिक केमिस्ट्री का है, लेकिन पूरा केमिस्ट्री डिपार्टमेंट का जो डीन है वो ये प्रशांत नंदी है। तो
अच्छा
यही फाइनल सभी काम करता है, मतलब सभी क्वेश्चन, फाइनल क्वेश्चन सिलेक्शन, क्वेश्चन फॉर्मेशन यही करते हैं।